We are going to look at mole ratios, which would be page 3 through 5 of homework packet 7. Here's our first equation. It's N2 plus 3O2 forms 2NO3. Let's make sure this is balanced. If there's no number in front, we assume it's a 1, so there's 2 nitrogens, 3 times 2 is 6 oxygens, 2 times 3 is 6 oxygen. So a mole ratio is actually just a ratio of the coefficients that you have in front of the molecules. So if there's no number in front of N2, it's a 1, and it would be a 1 to 3 ratio for N2 to O2. So I'm just going to text that in, just putting in the coefficients. 1:3 would be my ratio. What if I were looking for my ratio for nitrogen to NO3? It looks like it is 1:2. For every 1 N2, there's 2 NO3 produced. And the final one would be oxygen to NO3. Just take the coefficients, plug them in. It's going to be 3:2. Okay, how does that work down here for a different equation? Let's look here. We got 8H2, we got S8 forming 8H2S. We got 16 hydrogens, we got 16 hydrogens, we got 8 sulfurs, 8 sulfurs. Notice hydrogen, part of Brinkelhoff, travels in a pair, and sulfur is unusual. It doesn't travel by itself. Or part of Brinkelhoff, it's not part of that, but it does travel in an 8-pack. That's kind of an exception. But anyway, if we look at the ratio of H2 to H2S, it's 8 to 8. We could write that, or we could simplify that. We could say 8:8, or we could simplify that to 1:1. Either one is okay. Let's look at the H2 to S8. It looks like the ratio is 8:1. So I'm going to put that in there. 8:1. And let's look at H2S to S8, and that is also 8:1. Just what do these ratios mean? What this means, I'm going to go back to this equation, is N2 plus 3O2 forms 2NO3. It means 1 molecule of N2 combines with 3 molecules of O2 to form 2 molecules of NO3. Or you could say 1 mole of molecules combines with 3 moles of NO2 molecules to form 2 moles of NO3 molecules. So you're either comparing molecules or moles of molecules. What you're not comparing is grams. You can't say 1 gram of this combines with 3 grams of this to form 2 grams of this. That violates conservation of mass. Just like in sandwiches, 2 slices of bread combined with 1 slice of cheese to make 1 sandwich. Or I could say 2 dozen pieces of bread combined with 1 dozen pieces of cheese to make 1 dozen sandwiches. I could even say 2 moles of bread combined with 1 mole of cheese to make 1 mole of sandwiches. That would be a lot of sandwiches. However, it's not 2 grams of bread combined with 1 gram of cheese to make 1 gram of sandwiches. All right, let's go to the next question, number 3. I'm going to clear this out. I'm going to scroll down a little bit and my spotter, and we'll go do that. So 3 says, answer the following questions for this equation. 2H2 plus O2 forms 2H2O. So I could take hydrogen, and if I spark it with oxygen, it will tend to form water vapor. What's the ratio of H2 to H2O? It looks like it's 2 in front there, 2 in front there. So we're going to call that 2:2. I'm just taking those coefficients. Suppose you had 20 moles of H2 on hand and plenty of O2. How many moles of H2O could you make? All right, so the ratio is, I'm comparing hydrogen to oxygen. I'm sorry, hydrogen to water. It's just telling me I have enough oxygen to make that work, but that's not really part of it. So I could start with 20 moles of H2, and I'm going to times that by something. I'm going to times it by my ratio. So I'm going to put a little line here, and I'm going to put moles of H2 on the bottom, because that's where I'm coming from. And we said that was, from the equation, 2 moles of H2. And I also am going to put what I'm going to moles of water. So I'm going to put 2 moles of H2O on the top. Let's try this right here. So you could say, hey, if I have 20 moles of H2, it's the same ratio. It's got to be 20 moles of H2O. You can do that in your head. That's fine. This would be a way to do that through dimensional analysis. Either way, what's your answer going to come out to be? It's going to equal 20 moles of H2O. So you can do that in your head, or you could do that through dimensional analysis. But you should be able to see either way how that works. Okay, what is the ratio of O2 to H2O? I got a 1 here and a 2 here. So this time I'm going to say it's a 1 to 2 ratio. Suppose you had 20 moles of O2 and enough H2, so we don't have to worry about the H2. How many moles of H2O could you make? So if this were 20, my guess is the H2O is going to be twice as big. Okay, well, what's twice as big as 20? It's 40, or you could show that through dimensional analysis and start with 20 moles of O2, and then times that by, I'm going to draw my little line here. I'm going to put moles. It's not a very good line. I'm going to put moles of H2O on the bottom. And according to my coefficient there, I have 1 mole. I'm sorry, moles of O2 on the bottom. I have 1 mole of O2 there because there's a 1 is this coefficient. And I have 2 moles of water goes on top. 2, so I'm going to write that in. 2 moles of H2O right there. So I multiply that through and it equals 40 moles of H2O here. Now, could you just look at that and say, hey, if this is 1, this is 2, if this is 10, this is 20, if this is 20, this is 40. Yes, you could do that as well, or you could do this through the dimensional analysis. But that would be the ratio that we have here. Let's do one more example. I'm going to skip all the way to page 5 and do number 8. And so I think I'm going to clear this out, go and do that example up here. And let's see if I can scroll this. I think I have this above here. There we go. But this is number 8 on page 5 of your homework packet. The other things are on page 3. Sodium metal reacts with H2O to form NaOH and hydrogen gas. So if you put sodium metal in water, it actually gives off hydrogen gas. All right, how many moles of sodium are consumed if 92 grams of sodium metal react? This looks like a review of what we did before. This looks like it is a mole train problem. Woohoo! Okay, so I know I got 92 grams. Looks like I got to divide that by the molar mass to get to moles. And what's the molar mass of Na? Oh, it's right here. It is 22.99 or 23.0. So I'm going to do that right here. I'll do it with dimensional analysis. And I will say, what, 92 grams of sodium. And then what I'm going to do is I'm going to times that by, what did we say? I'm going to put grams on the bottom, draw a line here. And I said the molar mass was 23 grams. So I'll put 23 grams on the bottom, and it is 1 mole. So notice I'm saying times 1 mole over 23 grams, or which would be like 92 divided by 23 grams. And that comes out to a nice even number of 4.0 grams of Na. Okay, how many moles of hydrogen are produced if 92 grams of sodium metal react? Well, I know that 92 grams of sodium produce 4, I shouldn't have said grams here, I should have said 4 moles here. And this equation doesn't compare grams to grams, but it does compare moles to moles. So I can say, hey, for every 2 moles of sodium, I get 1 mole of H2. So I can take this and say 4.0 moles of Na, and then I'm going to times that by, I'm going to go through my mole ratio. I'm going to put on the bottom the moles of sodium, and I'm going to put the 2 from the equation there. So I'm going to say 2 moles of Na. And on top, I'm going to say, oh, I put the coefficient there, and that is 1 mole of H2. So for every 2 moles of sodium, I get 1 mole of H2. So it ends up being 4 divided by 2, which equals 2.0 moles of H2. Does that make sense? Well, if 2 moles of sodium give 1 mole of H2, then 4 moles of sodium should give twice as many moles of sodium. 4 moles should give 2 moles. So a 2 to 2 to 2 to 1 ratio would be the same as a 4 to 4 to 4 to 2 ratio. All right, good luck. Try these on page 3 through 5. Let me know if you have questions. Thank you.